Hey guys, welcome back to my channel. In this programming walkthrough, as I promised in my earlier video, that we will train a model using a machine learning technique or a machine learning algorithm. So today we are going to talk about linear regression. Okay. So what do we mean by linear regression? Is simply where data uh, is designed in such a way where one variable is dependent on another variable. What I'm saying, let's see our data set. So today we have advertising data. I will open it, and as you can see, here are four columns. Okay, so basically it's a advertising data where we are trying to find out if we are spending suppose this amount to like advertising it on TV, then how much sales we are earning. So we have spent 230 on TV, 337 on radio, and 69 on newspaper. So why this is dependent? Why I am calling this as a linear regression? Because here, if we change the amount of TV, the sales might be it might get affected. It may increase or may decrease. Suppose I am spending like 500 on advertising on TV, so then my sale will be go up, right? So that's why we call it linear regression, where one variable is dependent on another variable. Okay, and we will also understand the two key terms which we use. The first one is the predictive variable, and second one is the target variable. Okay, so what we want to achieve, we want to train our model to predict our sale prices. If we change any of these values, then what will be the effect or what will be the change in our sales value we want to predict with our model. Okay, so in this case, sales will be our target variable, and these three will be our predictive variable. Okay, so let's go ahead and see it in code how to perform this task. Okay, now for to save our time, what I have did, I have just written the code, and what I will doing, I will going to explain you step by step. Okay, how to run this, how to like train this model. Okay, so our first thing is we have imported warnings and we have filtered warning. So this is just to ignore any warning which we get in the code. So those are basically unnecessary depreciation warning which we get. And in my panda series, I have also like explained you how to use panda, or in how to use numpy and pandas to like cleaning the data, or to like doing some basic mathematical operation on data. Okay, so first we will import warnings. I am choosing my Python environment, and yes, then I am importing numpy and pandas. Numpy for some mathematical operations, and pandas for like loading the data and cleaning reading the CSV data and cleaning the data and doing stuff like that. Okay, so firstly, what I did, I have taken an advertising variable where I am going to read the Excel and save it into a variable. So that's a basically pandas data frame. Okay, so see, I am printing the head of that advertising. What head function does, it just print the top 5 rows of your Excel. So if you see, it's get printed. We have TV, we have radio, we have newspaper, and we have sales. Okay, now it's a good idea to first look your data or first analyze your data before training a model. Okay, so what we'll do, we'll first do some basic checks on our data. So first one is save. So save, as you can see, it's saying as 200 comma 4. It means we have 4 columns and 200 rows in our data. Okay, now info will tell us some basic information about data. Suppose what is the data type of the data. Okay, so TV is like float, radio is float, newspaper is float, and sales is also float. In my basic coding videos, I have shown you, I have told you like what are the different data types. So there you can refer that these data are float or integer or some other data type. Okay. Now to further describe our data frame, we use describe method. So we will get inside our data, like we get mean, we get median, and we get max of the data. Okay. So you might not be familiar with this 75, 50, 25. So these are the percentile. It simply means 25% of our data of TV is 74. Okay, 50% of our data is 149. So what we always interested in this three terms: mean, median, the 50% is the median, and the max, that is the maximum value. Okay. Now before training a model, we always like visualize our data to see the trend of our data or to find the pattern in our data. Okay. So for this, Python offers two libraries, like we use generally matplotlib is one and seaborn is one. Seaborn is like matplotlib only, but it's more advanced and more like dynamic one than matplot. Okay. So we import two libraries. It will help us to draw a graph of our data. Okay. So first type of graph is pair plot. Okay. What pair plot means, you will get multiple graphs. Okay, let me run it first and show it to you. Okay, so see, you got three graphs. We have mentioned here the variables xvar as TV, newspaper, and radio. Okay, so the first parameter we are giving is advertising. That is the name of our data set. What we want as our x values. So our x values will be, in first case it will be TV, in second case it will newspaper, and in third case it will radio. And y equal in y we always give our like target variable. So y our target variable is sales. We want to see the relation between TV and sales, newspaper and sales, and radio and sales. So this makes sense. Okay. And we will plot a scatter graph. So see how data is distributed. So imagine a line like this. Okay. So you can see, if we talk about TV and sales, the data is more centered about this line. Okay, it's hugging the line more closely. It's not the case with newspaper and radio. So we might say that the TV is the best like more the correlation between TV and sales are more than newspaper and radio. Okay. Another method to see the correlation is using heat map. So heat map is also type of chart which shows that the correlation between the variables. So if we run this, you can see the lighter shading means the the darker shading will always mean the high correlation, and the lighter shading means the low correlations. So if you see, the first row is TV and the fourth column is sales, you see the value is 0.9, which is like pretty good. So we are having a very high correlation between TV and sales, which we also get from this graph, right? The data is more like centered and hugging towards the center line, or we technically we say like best fit line. So it's hugging the data here. Yeah. And you can also see the like in our graph it's 0.9, which is like quite good, and which is not the case definitely with the newspaper and the radio. They are not like too much correlated with our target variable. So since the TV is like more correlated or more best suited for the sales, it's more dependent, sales is more dependent on the TV variable. In further video, we will consider TV as our predictive variable and sales as our target variable. Okay. So now we'll perform a simple linear regression. So simple linear regression has a equation. It basically means y equal to c plus m1 x1. What m1 x1 is? M1 is the coefficient of your first predictive variable, and you sum up all your predictive variables, and you add the intercept to get the value of like linear regression model. Okay. So in this example, we will use stat model library of Python to train our model. And what steps we are going to follow? Let me write it. Okay. So what steps we are going to follow? I will write steps. So first we will create x and y. So what is x and y? In x we put predictive variable, and in y we put target variable. Okay, so this will be our first step. Okay, second step what we can do is like train our we will split our data in train and test. So split our data in train and test. So basically when we train a model, first step what we do, in one variable we keep the predictive variables, and in other one we keep our target variable. Then we split our data. Suppose we have a 5,000 row, so on 3,000 row I will train my model, and in remaining 2,000 row I will test my model. So we split our data set in such a way uh, so that we can train our model and test our model on the same data set. Okay, now the third thing, obviously we are going to train our model. Okay, train model, and the last step will be we will evaluate our model. So how much our model is effective, we are going to evaluate our model. Okay, so these are some steps we are going to perform. Okay, okay, so as I told you, first we will create x and y. So in x we keep predictive variable, and in y we keep the target variable. Okay, now to train and to split our data in train and test, we use uh, train test split function in our sklearn model selection library. Okay, so let me, okay, oh, it's saying x is not defined. Let me run this and then run this. Okay, so what this basically means, the train trace split functions take x, which is our predictive variable, y, which is our target variable, train size 0.7. What does it means? On 70% of data we are going to train our model, and in rest 30% of data we are going to test our model. Okay, and that will be like random data. We try to take random rows from our data set, so that the result will be more fair. Okay, and it returned the x train, x test, and y train and y test. It returned us back. So we keep all these in our four variable: x train, x test, y train, and y test. Hope we are on the same page still here. Okay, now let's just go ahead and print it to see how the data look like. Okay, so as you can see, in x train we have the sum of the values of TV and some of the values of cells. Okay, and similarly in y train you can say it's the value of y. Okay, now so to build a model we need to import a library named as statmodel.api. Okay, so this model is required to perform the linear regression. So we will add this, import this library. Now what is the first thing, there is one limitation with stat model. It by default it does not add coefficient, or it does not add the coefficients, so we have to manually, by using add constant function, we use the coefficients. What the coefficient, sorry, the intercept, sorry for my mistake, the intercept. So first thing you can see, C is the intercept, so it doesn't include C by default. Okay, so that's why we use this add constant model. Okay. So we have imported the library, we have added the constant, and now we are going to train our model. Okay, so what this uh, OLS means? OLS means ordinary least square. Okay, or the full form of this is ordinary least square. We pass our to training data to this function, and the fit function basically train the model using this equation, the equation which we saw earlier, this equation, this one, and store it in a variable that is basically LR. So our model will be trained and it will be stored in the LR variable. So let's do that. Okay, now we will see some of the basic parameters of our model. Okay, so let me print this. So as you can see, the coefficient is 6, sorry, the constant is 6.9, and the value of TV which becomes is like 0.5. Okay, so what this basically means, you can write it something like this: 6.90 plus 0.054 TV, and here you can say cells equal. Okay. So the what the model will simply do, it will like this is the simple formula that get generated while training this model. So what will happen if you make the prices of the TV at 0? Okay, you expend 0 on advertising on TV, then your sales will be 6. And the same thing you can see here in the chart. Okay, when the sales is 0, sorry, when the TV is 0, the sales value is around 6, which like it's not so much clear, but yeah, we can have an idea that when this TV is 0, the some of the data point are hitting the value of 6. Okay, now where are we? We have trained the model. The last thing what we are going to see, we are going to print the summary of our model, how well our model has been trained. Okay, so in this we take we basically see some of the parameters. Okay, so first one is your R squared value. What is the value of the R squared? It's 0.81. Okay, so what this basically means that 81% of your sales value depend on this TV, our predictive variable. Okay, and the second thing you can see is F statics, that is 611, and probability F statics is 1.52. Okay, and we also consider this p value. See, so what as I told you, what the R squared means is like 86.6% of the variance of sales is explained by TV. Okay, so that's all for this video. In next video we are going to see some of the important concept like residual analysis, and I'm also going to train the model using some other algorithm that we'll see in our next video. Okay, thank you. Yeah, if you have any question, you can write in comment section and I'll try to answer.